Hello, everyone. This is Dr. Kenneth Ta. Today, we are going to consider Chapter 4. Chapter 4 is time value of money. So we are going to be talking on time value of money. Time value of money. That is Chapter 4. Time value of money is the whole idea that money today does not have exactly the same value like in the future. And when we consider a certain amount of money in the future, it doesn't necessarily have the same value like today. So we want to consider the value of money at a particular time. For us to do that, we are going to cover our future value, we'll cover present value, we'll look at some rate of return, and then we'll do an application of time value of money that we call amortization. So the first thing I want us to understand is that there are different cash flows. We need to understand different cash flows. There are different cash flows, and based on those cash flows, we calculate present value and future value differently. So the first kind of cash flow that I want us to talk about is what we call the lump sum, which is one amount of money, just one. If I expect to receive $5,000 in 3 years, and that is it, that is a lump sum. In 3 years, I'm going to be getting $5,000. So we can look at this example, a $100 lump sum at the end of 2 years. So you notice that year one comes and it's over. Year two, there is a $100 lump sum. So that is a lump sum. The second type of cash flow that we want to talk about is what we call an ordinary annuity. An ordinary annuity. An ordinary annuity just basically implies the cash flow comes at the end of each period. So for example, ordinary annuity of a $100 per year for 3 years. So the cash flow will look like this. At the end of year one, we get a $100 cash flow. At the end of year two, we get a $100 cash flow. And at the end of year three, we get a $100 cash flow. So that is an ordinary annuity. It's cash flow that comes period after period for a finite period of time. And that cash flow comes at the end of each period. Yes, we also have what we call annuity due. It's similar to ordinary annuity, but the cash flow comes at the beginning of the period, So for ordinary annuity, the cash flow will come at the beginning of year one, at the beginning of year two, and at the beginning of year three, right? We also have what we call uneven cash flow. Uneven cash flow is cash flow that comes, it's not the same amount period after period, it's uneven. So we can look at this timeline. This is a perfect example of an uneven cash flow. The amounts differ. At the end of year one, there's 100,000. At the end of year two, another amount, 75,000. At the end of year three, another amount. So the cash flow is uneven. So those are the different types of cash flows we have. So in this chapter, we are interested in calculating the present value and the future value of these different types of cash flow, the present value and future value of a lump sum, of an ordinary annuity, of an annuity due, of uneven cash flow, of uneven cash flow. All right, so let's look at the first set of problems on future value. Future value. How we calculate the future value. So this problem says, what is the future value of an initial $100 after 3 years if it is invested in an account paying 10% interest annually? What is the future value? So there are different ways we can do this kind of problems. We can use a formula. We can use our bar 2 plus financial calculator, and we can use Excel. So if we are using the formula, future value is equivalent to present value times 1 plus interest raised to the power n. So that is the formula to calculate future value. Again, future value is equivalent to present value 1 plus I for interest raised to the power n for the number of period, All right, let's look at this problem one more time. What is the future value? So future value is what we want to calculate of an initial $100. So the present value is $100. The present value is $100. So we have $100. So this is equivalent to $100. One, if it is invested in an account paying 10% interest. So the interest rate is 10%. So this is plus 0.10, 10%, and that is what is the future value of an initial $100 after 3 years. So the period N is 3 years. So once we compute that, we should get 133.10. So dollars. So this is the answer. So that is going to be the future value. So this is how we compute this problem using the formula. We have the formula for future value. We are given present value, we are given the interest, we are given n, the number of period. We input that in the formula, and we are able to calculate the future value. We can also use Excel in calculating this problem. Once we set up our Excel in such a way that we have our time value of money function, then we go to our Excel page. All we need to click is to click the future value, because that is what we are interested in calculating. Once we click the future value, it is going to open up in such a way that it will want us to input the different variables that are given. It's going to ask for the rate. In this case, our rate is 10%. We input 0.1. It will ask for the number of period, which will be 3. It will ask for payment. This is a lump sum, so we don't have periodic payment. So the payment is 0. It will ask for present value. So we need to give it a negative present value, because money needs to go out so that money can come in. Money goes out so that money can come in. So what we are going to do is we give a negative present value, and since we're trying to calculate the future value, once we take enter, it will give us our answer, which is 133.1. So we can try that using the future value wizard on Excel. So we can do this problem either using the formula, or we can use Excel, or we can use our financial calculator. If we are using our financial calculator, all we need to do is to also input the different functions that are required, and then we compute future value. So in that case, we will first start by typing 3. So I'll take 3 for n using the financial calculator, which is number of period. I will take 10, and then I'll type on my financial calculator bar 2. I'll press I/Y, and then I will take negative 100, and I'm going to input present value. And then I will take 0 for payment, and I want the calculator to compute future value. So I'll press compute and then future value, and it will generate an answer. So that answer is going to be 133.10. So that's how we can calculate these problems. Again, 3 ways. We can either use the formula and calculate it out, or we can use Excel, or we can use our bar 2 financial calculator. All right, so that is how we calculate present value, future value. The next set of concept we want to capture, number 2, is present value. How do we calculate present value? Again, from the formula of future value, we can calculate the present value. So we had said before that future value is equivalent to present value 1 plus I for interest raised to the power n. So we can make present value the subject. So that implies present value is future value 1 plus interest raised to the power n. So this is the formula for calculating the present value. Again, present value is future value divided by a discount factor, and that discount factor is 1 plus I for interest rate raised to the power n, raised to the power n. So we can look at a simple example. So let's look at this example above, question number 2. It says, what is the present value of 100 to be received in 3 years if the appropriate interest rate is 10%? If the appropriate interest rate is 10%. So notice that everything is given except present value. So we can easily put this into the formula to calculate. So in the future, it says, what is the present value of $100 to be received in 3 years? So to be received in 3 years, it means that is the future value. So the future value, so we can say this is equivalent to future value is $100. N is 3 years, interest rate is 10%. So it's 1 plus 0.10 raised to the power 10, raised to the power 10. So if we compute this out, we are going to have 75.13, 75.13. So that is the answer we get when we use the formula. Again, we can also use Excel. If we are using Excel, we type in the present value function. It will ask us for the rate, which we are going to input it. And that rate is going to be 10%, which is 0.1. It will ask us for the number of period, which we will input at 3. It will ask for the payment, which is 0. Because it's a lump sum, we don't have periodic payment. It will ask for future value, which we take negative 100. And we had pressed present value. So it's going to give us the present value of 75.13. 0.13. So again, the way this works, you just go to Excel and you press present value. Once you press present value, it is going to ask for interest. It is going to ask for number of period. It is going to ask for payment and future value. So you basically just input interest 0.10, comma, and for number of period is 3, comma, the payment is 0, comma, the future value is minus 100, enter, and that is going to give us 75.13. So that is using Excel. We can use the financial calculator in computing this problem. So if you have bar 2 financial calculator, again, you start with the numbers and then you identify the variable that is concerned. And at the end, you press compute present value. We are interested in calculating the present value. So we are going to take 3 and then we press N. We take 10, we take I/Y. So notice when we are using our financial calculator, instead of inputting interest rate as 0.1, we tend to input our interest rate as a whole number. So in that case, this is 10, and then we'll take 0 for our payment. We will type 100 for future value, and then we'll press compute present value, and that is going to give us 75.13. So that is how we use the financial calculator in computing this problem. All right, so we have seen how to calculate present value. We have also seen how to calculate future value. So we want to go to the third assignment, which is finding time. And this comes straight away from the formula of present value and future value. So time is n. We just need to make n the subject. So it's making n the subject. And again, there are 3 methods within our control. We can either use the formula, or we use the Excel spreadsheet, or we use our financial calculator, or we use the financial calculator. So let's look at this problem. So this is an example. It says if a company's sales are growing at the rate of 20% per year, how long will it take sales to double? So how long? So that is the time period. That's the time period. How long will it take sales to double? So if we were to do this problem, let's use the formula method. We know that future value is equivalent to present value, 1 plus I raised to the power n. So we are interested in n. We're interested in n because that is the time period. How long will it take? All right, so we are not given present and future value, but we are told that how long will it take its sales to double? So if we assume a present value of 1, to double means that the future value becomes 2, 1 plus the growth in this case is going to be the interest rate, which is 20%. So this is plus 0.20, and we're interested in calculating n. So if the interest rate or the growth rate is 20%, how long will it take to move present value from 1 to 2? How long will it take for sales to double? So we're interested in calculating n. We're interested in calculating n. So what we can do is to make n subject. So here we have 2 is equivalent to 1.2 raised to the power n. So we can take the ln of both sides so that n should come down. So this is going to be ln 2, which will be equivalent to n ln 1.2. So when we take this ln here, this n comes down, which means our n is going to be equivalent to ln 2 divided by ln 1.2, which if we do that, we'll end up with 3.8. 3.8. So it's going to take 3.8 years for sales to double. So that is using the financial, that's using the formula. For us to use Excel, we will just take equivalent to. The function we need is number of period. If we do that, then Excel will ask us to input our I for interest, input our payment, input present value, input future value, which we can do that. So it is n number of period, interest rate is 0.10, payment is 0, present value will take a negative, money needs to go out so that money can come in, so -1, future value is going to be 2, enter, that is going to give us 3.8. So that is using our Excel. If we are using the financial calculator, then we are going to take 20i/y for interest rate, -1 for present value. We can take 0 for payment, 2 for future value. We ask the calculator to compute for us n, which is going to give us 3.8. So that's how we'll do this problem using our financial calculator. So that is working with n, which is the number of period. All right, we will go to our next concept, which is solving for I, which is that interest rate. Solving for I, which is that interest rate. Again, it's going to be the same. We have the formula for future value, which from there we can infer present value. And if we are given everything except I, the interest rate, we can always solve for the interest rate. All right, let's look at this example. It says if you want an investment to double in 3 years, what interest rate must it earn? What interest rate must it earn? So n is 3 years. Again, if we want that investment to double, it means that if the present value is 1, future value is going to be 2. So we can solve this first by using the formula. If we are using the formula, then future value is equivalent to present value 1 plus I for interest rate raised to the power n. Present value is 1. We want it to double, so future value is 2. 1 plus I in 3 years. So you see, the only thing that is not given is I, and that is that interest rate that we are looking for. So we need to isolate I, make I the subject. All right. For me to proceed with this problem, I need to bring down raised to the power 3. So I multiply both sides by, excuse me, I multiply both sides by the power 1 divided by 3. So this is 2, 1 on 3, which will be equivalent to 1 plus I, 3 times 1 on 3, so that the 3 can cancel out. So that is how I'm going to knock off raised to the power 3. So if I do that, I can proceed to making I stand on its own. So I have 1 plus interest is equivalent to 2, 1 on 3. So I is 2, 1 on 3 minus 1. So if I work that out, I will end up with 25.99%. So that is the interest rate. That's the interest rate, 25.99%. Okay. So if I am using Excel, so I'm going to basically take rate in Excel, which is the I function. So I'll type equal to rate, and Excel will recognize this and will want me to input number of period, payment, present value, future value. So I'm going to take rate. Number of period is 3, payment is 0, present value -1, future value is 2. Once I do that, I will end up with 25.99. So percent. Okay. And I can also use financial calculator. So in that case, I will take 3 and I'll type in my financial calculator, -1 present value, 0 for payment. I'll take 2 for future value. I want the calculator to compute interest. Interest with the financial calculator is I/Y, and it's going to give me 25.99. Okay. So we have worked with lump sum, and we have seen how to calculate the present value, the future value of a lump sum amount. We have also seen how to calculate N, which is the number of period, and how to calculate I, which is the interest rate. All right, we want to look at another stream of cash flow. This time we want to look at annuity. And we're interested in calculating the future value of an ordinary annuity. And then we'll also discuss an annuity due. So we have defined an annuity as a cash flow that comes in the same amount, period after period, for a finite period of time. It's the same amount, period after period, for a finite period of time. So if we look at this problem, what is the future value of a 3 years ordinary annuity of $100 if the appropriate interest rate is 10%? So this is a 3 years annuity. It means that at the end of year 1, we are going to have 100. At the end of year 2, at the end of year 3, we will have $100 each. So how do we go about calculating this problem? We can use formula, we can use Excel, we can use the financial calculator. So if we are using the formula, this is future value. So future value of an ordinary annuity is going to be equivalent to payment 1 plus I for interest raised to the power n minus 1 divided by I. So that is the formula of an annuity, of future value of an ordinary annuity. So now we can take the problems that are concerned, the different variables that are given, and feed them into the formula. So what is the future value of a 3 years ordinary annuity of 100? So you see now that we have payment. So unlike lump sum computation where payment was 0, in this case, ordinary annuity of $100. So the payment is $100. The interest rate is 10%. So this is plus 0.10. And future value of 3 years is 3 minus 1 divided by 0.10. If we flush this out, we end up with 331. 331. So this is how we will do this problem using the formula. We can also use Excel. So if we are using Excel, it's the same like before, except that we now have payment. So future value is what we press. So say equivalent to future value, equal future value. It will ask for I, it will ask for N, it will ask for payment, and it will ask for present value. So the I, which is the interest rate, future value is 0.10. When it asks for interest rate, that's why we put comma, and the number of period, which is 3 comma, payment negative 100, and then present value is 0. And then if we press enter, that is going to give us 331. The same, if we are using the financial calculator, then we are taking 3 as N, we are taking 10 as I/Y, we are taking 0 as present value, we are taking negative 100 as payment, and we want the calculator to compute for us. Compute future value, which is going to give us an answer of 331. So that is how we will do this problem using the financial calculator. So that is the future value of an ordinary annuity. Let's look at the present value of an ordinary annuity. The present value of an ordinary annuity. So what is the present value of an annuity? So we can look at this problem, and number of period is given as 3, interest rate is given as 10%. The payment that comes periodically at the end of every period is $100. So what is the present value of this annuity? Or if you were to buy this annuity, what is the value? How much are you going to buy? It's going to be the present value of all future cash flow, of all future cash flow. So if we are using the formula present value, again, we are talking about an ordinary annuity is going to be the payment times 1 divided by I, the interest rate, minus 1 divided by I, the interest rate, 1 plus I, the interest rate, raised to the power n. Okay, so that will be the formula. Okay, so payment is 100, interest rate is 0.1 minus 1 over interest rate 0.1, 1 plus 0.1 raised to the power n, which is 3. And if we work this out, we end up with 248.69. Okay, so that is using the formula in calculating this problem. We can also use our financial calculator. If we are using our financial calculator, then all we need to do is to take 3 as n, 10 as I/y, 100 as payment, 0 as future value, compute present value, and we are going to have negative 248.69. And that is because payment was not taken as negative. If we take negative for payment, then we have plus. If we leave payment to be positive, then future value is going to be negative. So we throw away the negative sign, and the correct answer is 248.69. All right, and we can do the same. We can do the problem using our Excel. So with Excel, we are going to press equal present value. It will ask for rate, which we type 0.01. It will ask for number of period 3. Payment, you see now we take negative. And enter. That is going to give us our present value, which is consistent with the formula and the financial calculator. Yeah. So now we want to step it up and look at how we calculate annuity due. So we have seen how we calculate ordinary annuity. Now we want to work on an annuity due. All right, for an annuity due, it is the same as ordinary annuity, except that there is one additional period. So we had defined ordinary annuity as series of cash flow that comes period after period for a finite period of time. But this cash flow comes at the beginning of the period. With an annuity due, the cash flow comes at the beginning. Ordinary annuity, the cash flow comes at the end of the period. Annuity due, the cash flow comes at the beginning of every period. So if you think of how salaries are paid for most people, it is the same amount of money period after period, but the cash flow comes at the end of the period. So that is an ordinary annuity. But if you were to imagine that you are being paid at the beginning of the period before you go and work, then if it is the same amount of money period after period, that becomes an annuity due, And if the money is coming early enough, you will benefit from one additional period of compounding. Because if I'm starting right now to invest my money in the bank and you do the same, and mine is set up in such a way that compounding is done at the start of the period, So if I put that money, or let me say this, if I put that money now, and then you put your own at the end of the period, I put it at the beginning of the period, you put yours at the end of the period. By the time you are putting your own money, mine must have been in the account for 1 year. So interest will accumulate. At the end of the day, I'll be better off than you because of the power of extra compounding. Right, so we'll see how we take that extra compounding into consideration in calculating this problem. So let's look at example number 3. It says, what will be the future and present value, or what will the future and present values be if the annuity were an ordinary annuity, or were an annuity due, if it were an annuity due. So it's the same kind of problem if we are using the formula to calculate the present value. So this will be equal present value, and it's going to ask for N, for I, interest rate N, number of period, is going to ask for payment, is going to ask for future value. Okay? So this on its own is an ordinary annuity. So let's do this. Let's start with the future value. So let's start with future value, and then we'll come to present value. Yeah. So the future value of an annuity due is going to be the future value of ordinary annuity, then times 1 plus I, which is an additional compounding. So times 1 plus I. So notice when we do time value of money, future value is growing by 1 plus I. So future value is present value growing by 1 plus I. Okay? So since there is one additional compounding period with annuity due, then ordinary annuity will be, then annuity due will be ordinary annuity times 1 plus I. Okay? So we already saw future value of an ordinary annuity, which is 331. So the one additional period is going to be 1 plus interest rate is 10%. So this will give us 364.10. So the future value of an annuity due will be much higher because of one additional compounding, because of one additional compounding. Okay? If we are using Excel, then we need to specify the type. So if we take equal future value, Excel is going to ask for rate, is going to ask for number of period, for payment, for principal, and for type. So this type, that's what is very important. So if we are doing ordinary annuity, then the type is going to be 0. But if we are doing annuity due, the type is going to be 1. So rate 0.10, number of period 3, payment minus 100, present value 0, type 1. That 1 is so that the computer Excel can recognize that this is an annuity due. So when we do that, we are going to have 364.1. So notice for ordinary annuity, the same thing, but with the type, we now need to put 0. For annuity due with the type, we need to put 1. And that is if we are working with Excel. If we are doing using financial calculator, there is a switch we need to make. So we need to switch from N and put begin. This is a little bit technical, but once we do this, we can do the same to remove the begin. So we are going to set begin mode. We'll set begin mode. So we are going to switch the calculator from the N to the begin mode. Yeah. And then we are going to take 3 and 10 I/Y for interest rate 100, payment 0, present value, compute future value. This will give us 364.10, consistent with our computation using Formula O Excel spreadsheet. Okay, so for present value of an annuity due, present value of an annuity due. So it's the same kind of concept. So present value, annuity due, this is equivalent to present value, ordinary annuity times 1 plus 5 for an extra period. So we had seen present value of an ordinary annuity. We just go back and we take the answer. Otherwise, we compute it, which is 248.69 times 1 plus 0.1, and that will give us 273.56. Yeah. So that's how we do it using the formula. If we want to do it on spreadsheet, so present value, we take equal present value. It is going to ask us for rate, number of period, payment, future value, type. So our type is going to be 1 so that the computer recognizes that this computation is for an annuity due. And future value is 0. We don't have any future value. So rate is given as 10%. Number of period is 3. Payment is minus 100. 0. Put 1 to recognize it is an annuity due. Enter. So the present value becomes 273.55. Okay, consistent with the formula. Okay, and if we were to do financial calculator, it should be at the begin mode. Then we take 3N, we take 10 I/Y, we take 100 payment, 0 for future value, compute present value. Okay. All right, let's look at uneven cash flow. Uneven cash flow. So uneven cash flow. So notice this is an example of an uneven cash flow, 100, 300, 300, and negative 50. So the cash flow is not the same. So in calculating the present value, for us to do this kind of problem, we are going to calculate the present value for each value, and then we sum them up. We sum them up. So it's going to be sum of present value, which is sum of future value, 1 plus interest rate raised to the power n. Okay. So we do them one at a time. So in this case, if we put them on a timeline, we can calculate the present value of 100, which is going to be 100 over 1 plus interest rate, which is 0.1 raised to the power 1, which is going to be 9.91. And then we do present value for 300, present value, 300, the next one, present value, negative 500. So that is all the different present value we have. Then we add them up. Once we add them up, we have 530. So this is how we solve it. So we basically just calculate the present value for each of these cash flows and we add them up. And we add them up. Okay. Two things I want to emphasize. One of them is compounding more frequently than annually. Compounding more frequently than annually. So we have been working with cases for which compounding, which means the calculation of interest is done once in a year. There are situations where compounding is done more frequently than annually. So in this case, we make adjustments. The adjustment we make is on the number of period and adjustment on the interest rate. So if M is equivalent to number of compounding, if you think about it, if compounding is done semi-annually, it implies that M is going to be 2. Or compounding will be done every 6 months. If it is done quarterly, then M is going to be 4. If it's done monthly, M is going to be 12. If it is done daily, M is going to be 360. So the adjustment we make on the formula is that future value is equivalent to present value 1 plus I, and this is IN. So we divide this by M for number of compounding. And here we have N, we multiply it by M for number of compounding. So M is number of compounding. So that's the adjustment we make when we are compounding more frequently than annually. So we make an adjustment where we divide the interest rate by the number of compounding and we multiply the time period by the number of compounding. That makes our computation easy. So if we look at the case where compounding is done quarterly, for example, so find the future value with quarterly compounding. So with quarterly compounding, we see this adjustment. So we take I, the interest rate, and we divide by 4. We take the number of period and we times by 4. So in that case, we can basically just say, so if we are working with this case, future value is present value. So this is 100. So this is 100. 1 plus interest rate is 12%. So 0.12 divided by 4, because it's quarterly, raised to the power. Number of years is 5 times 4. 5 times 4. And if we flush this out, we are going to have 1.142.58. Okay. So that's how we make this adjustment. If it's monthly, we make similar adjustments. Semi-annually, we make adjustment likewise. All right, the last thing we should look at is the concept of amortization. And from amortization, we can actually build an amortized table. So this is an application of time value of money. What is the annual interest expense for the borrower and the annual interest income for the lender during the 2 years? Okay, we need to go up further. It says, what will be the required payment? What will the required payment be on a 1,000 loan that is to be repaid in 3 installments at the end of each 3 years if the interest rate is 10? So this is the kind of thing that is considered when you take a loan. So if you take a loan, this question is, what is the payment that you need to make, periodic payment over the life of that loan, so that this payment is satisfying both the interest and the principal amount, so that at the end of that period, everything is paid off. So this comes from the concept of ordinary annuity. So if we use the ordinary annuity formula and we make payment the subject, we can calculate that amount that is needed, the amount that is needed. Otherwise, we can just use our financial calculator or our Excel spreadsheet. So 3 as N, 10 as interest, which is I/Y, negative 1,000, the amount we borrow, as present value, 0 as future value. So we are interested in the payment. So compute payment. Once we do that, it will give us 402.11. 402.11. Okay. So this is the amount that is needed to pay off the interest and principal of the loan. And we can actually put this in an amortized table. So this is an amortization table. So it shows that amount that is being paid. So N is the time period. This is the beginning balance. This is the payment. This is the interest payment, principal, and end amount. So the argument is that this 402.11, so the argument is that we make this payment periodically. So we pay year 1, we pay year 2, we pay year 3, and that is enough. That is going to pay off our loan. It will pay off both the interest and the principal periodically, so that at the end of the life of the loan, we have paid everything. So on this table, we can see, so it's 3 years loan, so it needs to be paid over 3 years. The beginning amount is 1,000. So what we do is that you pay the amount that we calculated, which is 402.11. So when we pay this, how much of this goes to interest? The amount that goes to interest is really based on the interest rate. So we are told the interest rate is 10%. So if we look at this 10%, 10% of 1,000, which is 100. And we are paying 402.11. So 402.11 minus 100, the remainder is 302.11. So this one goes to the principal. And then if we take the initial amount, 1,000 minus this principal payment, which is 302.11, we end up with 697.98. That is the balance at the end of year 1. So we bring that balance here at the beginning of year 2. The same amount is paid. We calculate 10% of this beginning balance, which is 669.7. So we take this payment that was paid minus 69.7. The rest goes to the principal. So this principal is reducing the beginning balance. So the ending balance is 365.56. We take that to go, that becomes the beginning balance year 3. Regular payment is made. 10% interest, 10% of the beginning balance is 36.56. We take 36.56 off of the payment that was made, 402.11. That goes to the principal, which is 365.56. And that subtracts from the original, and it leaves us with an end balance of 0. So that is the power of amortization. So you see that this payment amount, if we keep making this payment over the life of the loan, we are paying off interest and the principal. So that's what happens when you take a loan, maybe student loan or mortgage, and you are making periodic payment. So every time you take a mortgage, the bank is going to provide you an amortization schedule that shows you how this periodic payment is reducing your principal, paying interest charges, so that at the end of the life of that loan, your balance becomes 0. All right, so this is where we are going to in this chapter.